Okay, so today we will be looking at applying our properties of quadrilaterals that we learned last time. So I want us to hopefully have the notes out from last time so we can use them. I wanted to touch base on the formulas that we should kind of have down by now, or really start working on getting those down. So our midpoint one, adding the x's dividing by 2, adding the y's dividing by 2, and getting a single point, an xy coordinate. Okay, the distance formula, where we just find the distance between the two x coordinates and square it, add it to the two add it to the distance between the two y coordinates and square it, and then our slope, which is our change in y over our change in x, or y2 minus y1 over x2 minus x1. Okay. Okay, so we are starting our exploring properties or applying properties of quadrilaterals with ABCD, and that is a rectangle. AB is 9 and BD is 12, so if we start marking our drawings here as we go, we see AB is 9. Okay, that's a 9, I promise. And BD is 12. Okay, so our diagonal here, the whole length of this diagonal, okay, is 12. I want to find the lengths of BC. Okay, I want this length here. Okay, I want to find AD. I want to find DC. And I want my other diagonal, AC. Okay, so we need to pull up our properties of rectangles so we can start marking our drawings. Okay, we should see that rectangles have two pairs of opposite congruent sides. So if AB is 9, then DC should also be 9. Okay, this is our other pair. So when we find BC, we should know that it's the same as AD. Okay. We should also take note that their diagonals are congruent as well. So if this side over here, or this diagonal is 12, then this diagonal is also 12. So AC is also 12. Okay. We need to take note that they have four right angles. Sorry. So these angles are all right. Okay, and from there, we can use the Pythagorean theorem because we're dealing with a right triangle and we have two side lengths. So let's look at finding this side. We'll call it x. Okay, so if we want to look at that, we can look at this triangle right here. Okay, with side lengths 9 and x and a hypotenuse of 12. So we can say that x squared plus 9 squared should give us 12 squared. Okay, that's just the Pythagorean theorem that says a squared plus b squared equals c squared. C is always our diagonal. Okay, so this should give us x squared plus 81 equals 144. All right. Then we subtract 81 from both sides and we get x squared equals 63. Okay. We need to take the square root of both of these to find that. So when we take 63, we'll put it up here. If we can break it down, you can break it down to 7 and 9. 9 can be broken down into 3 and 3, and that 3 can leave. So x is then 3 root 7, meaning this side AD is length 3 root 7, sorry. Okay, and also BC is 3 root 7 for the same reason. Okay. Next we have PQRS is a parallelogram. Okay, so again, I want to start making markings on my diagram here. So I have that PR is 24. Okay. 24 for that entire length of PR. I have that SM, so just from S to M, is 8. Okay, I have that PQ, okay, is 3x plus 2. All right, and I have that SR is 2x plus 9. 2x plus 9. Okay, I want to find QS, so I want to find the other diagonal, the entire length of it. I want to find what SR is, so I need to solve for the x there and figure out that side length. And I want to solve for MR, so the other half, or the half of that diagonal PR. Okay, so things that we know about parallelograms. They have two pairs of opposite parallel sides, right? They have two pairs of opposite congruent sides, okay? So this side, PS, is congruent with QR, and PQ should be congruent with RS. Now that we have PQ and RS and we know that they're congruent, we can set them equal to each other to solve for that x. Okay, so we can take 3x plus 2 and set it equal to 2x plus 9. All right, then it's just a simple algebraic equation. All right, if I take 2x away from both sides, I end up with x over here. If I take 2 away from both sides, I end up with 7 over here. Okay, if I am looking for side length SR, I want to plug 7 back into x and have 2 times 7 plus 9. This gives me 14 plus 9, okay, which gives me 23. All right, so SR is 23. Okay. Let's break some other properties down. Okay. So we know that our diagonals bisect each other in a parallelogram. So if I have that PR is 24, I should see that I'm bisecting, okay, into two congruent segments, meaning if I'm splitting 24 exactly in half, MR should give me 12. Okay, and again, if I'm talking about the diagonals bisecting each other, okay, then QM should be the same as MS, and we know MS is 8. So QS as a total should be 16 when I add both of those halves together. Okay, that's a 1/6 there. Okay. Again, all we are doing is marking our drawings with the knowledge that we are given. Okay, we're given that it's a parallelogram, which tells us a lot about it. We need to review our properties of parallelograms a little, and then we're marking it with each of these pieces of information that we're given, okay, and finding what we can based on that. So here we're given a rhombus again. It happens to be PQRS again. We know it's a rhombus, okay, because that's what we're told instead of a parallelogram like last time. So a rhombus should tell us that, one, all of our sides are congruent, right? That's one of our properties. And we are told that PR is 20. So this whole diagonal is 20. Okay. We're told that MQ, okay, just half of this diagonal is 24. Okay. And I want to find the length of each side. Okay. So I want you to think about this for a second, maybe pause the video if you need to, and think about how you could set this problem up given you have an entire diagonal here, given you have this half a diagonal here, okay, given what you know about the diagonals of a rhombus, maybe go back and review those from your properties of quadrilaterals notes, okay. Pause the video for a second and then come back to it once you have some sort of idea of how to approach this problem. Okay, so hopefully you found some clue in your quadrilateral notes as to where to go from here, but the diagonals of a rhombus bisect each other, or I'm sorry, bisect one, right? And we know that, no, they bisect each other. We know that when they bisect each other, or when they intersect at exactly 90 degrees, meaning we have right triangles again that we can use. When we have right triangles, we can use the Pythagorean theorem. Okay, so we have our side length here of 24. Okay, one of this other diagonal is bisected. Okay, so this side length should be 10 over here and 10 here. Okay, and 24 over here. So now we have this triangle. Okay, if we redraw it out here, okay, we have a 90 degree here. All right, our hypotenuse, the one across from it, is what we're looking for. Okay, then we have a side length of 24 and a side length of 10. From there, it's less important where you put those numbers, because again, it's just a squared plus b squared equals c squared, making sure that our c squared is our hypotenuse. Okay, so we can just take 10 squared plus 24 squared equals x squared. All right, from there we get, we want to take the square root, right, of 676. So that's 10 squared plus 24 squared, and that'll get me x once I take the square root here of these. Okay, when I break 676 down, okay, we can do this off to the side, 676. Okay, we can take a 2 out and a 338. Okay, from 338 we can take 2 out again, and we get 169. And 169 is a perfect square, so we get 13 and 13, which means we can now take out 2 times 13. Okay, so x just gets us exactly 26. It can come out of the square root sign because we found 2 pairs and nothing was left inside our square root. X equals 26. We need to come back to the problem to remember what we're solving for here. We're finding the length of each side. Each side is our hypotenuse in all of these triangles. Okay, so that means each of these sides has length 26.